classical computers have changed the world, and quantum computing is now going to produce the next generation of revolutionary technology. We'll be able to do things with quantum computers that we have never been able to do before.
We are able to find hints for new physics beyond what we know today and to probe the validity of theories.
Can we push the length of the longest, most precisely measured number ever put together by a human being one further?
It could be endless technically if one would imagine that this can work in the end.
The basis for turning all of this into reality could possibly be ion trapping. A charged particle, an ion, is trapped using electric and magnetic fields. The particle can be anything from a single atom to a dust particle as long as it is charged. The ion is trapped for very long times, longer than in any other device in atomic and molecular physics. Ions can be cooled down, and thus it's even possible to create crystals like these. Due to the extremely good control of the environment, it's the technique of choice for precise measurements.
We are looking as close as possible, as precise as possible in order to find somehow deviations, tiny deviations from the expected behavior, because that could exactly be that point which could point us to new physics.
The possibilities are endless and yet incredible. We can think of super-fast computers, the so-called quantum computer, not comparable with anything we know today. It could also make atom clocks even more precise, allowing for extremely accurate position measurements, for example, using GPS. Or to measure whether fundamental physical constants are really constant in time. The possibility of preparing and diagnosing quantum states of individual atoms and molecules in ion traps opens the way to shed new light on chemical reactions, or even to investigate antimatter.
The action has created a network of ion trappers from 16 different countries in Europe. There are some international partners. We have built this network in order to share information, and also not only for the different groups to share information, but also to make a common effort to train our students. People were extremely happy to meet in these events, to meet people from other colleagues from different backgrounds, to talk to them, to meet new people.
Certainly the subject of quantum information is a very global topic, and so it's important to have forums where people from all around the world and all levels, from students to senior researchers, can gather. And the Cost Action has certainly done that.
We know that if you can just come up with the right way of understanding the problem, there will be a way of understanding how to fix it. And that's fairly unusual in most of what we do in life. There are lots of things that are not under our control, and sometimes there just simply isn't a fix. With trapped ions, there usually is, and it's just a matter of time until you figure it out.